welcome to the Digital Media Academy speaker series for leading STEAM educators and school leaders. My name is Chris Bennett. I'm so pleased to be hosting this series that's focused on the challenges of facing K-12 school leaders in preparing young leaders for the fields of tomorrow. Today's session is entitled The Power of Data Science for Learning Experiences, and I'm pleased to shortly introduce you to our guest, Victor Lee. But before I introduce Victor, I would like to introduce myself and share briefly about Digital Media Academy. My name is Chris Bennett. I'm a longtime video game designer and an affiliate at Stanford Graduate School of Education. I'm also the engagement specialist at Digital Media Academy. Now, Digital Media Academy was founded in 1999 on the campus of Stanford University, and our flagship program, Leading STEAM Schools in the World, is a membership program that offers a complete, ready-to-use solution for K-12 schools that combines comprehensive STEAM curriculum, tailored consultation, and a supportive global community that empowers educators to meet the demands of 21st century learners. This public speaker series is brought to you by the Digital Media Academy team and is available globally through the leading STEAM schools in the world community. So why are we here? This series aims to connect you with leading thinkers and change makers to unlock the tools and knowledge needed to lead K-12 education change. Without further delay, it's my pleasure to introduce you to Victor Lee, our guest for today's session. Victor is an associate professor in the Graduate School of Education at Stanford University and leads the Data Interactions in STEM Teaching and Learning, also called the DISTAL Lab. He is also the faculty lead for the Stanford Accelerator for Learning. Through his research, he asks what future-facing STEM knowledge, tools, and practices are important to know to enable active participation and critical engagement with our increasingly digitally infused lives. He then uses the tools of educational design research to create examples for how we could get there. I would like to invite Victor to join me on screen now. Hi, Victor. Thank you so much for being with us.
Hi, Chris. Thanks for having me.
So first question, tell us a little bit about your journey. How do you find yourself in this wonderful space that you're in right now?
That's a great question. Well, I would have to say that I've had, for as long as I can remember, a fascination with how people learn and make sense of new ideas. And it was always a really intriguing puzzle for me as to why some topics, particularly those in STEM fields, felt really hard for some individuals. And what could we do with respect to technology that could make it more accessible? To make those ideas more understandable. So what that did is that it led me, as I pursued post-secondary education, to pursue majors in cognitive science, which is really focusing on cognitive processes, how people think and learn. It was one of the early places where artificial intelligence was being actively discussed, and also a degree in mathematics. And the motivation there was I wanted to really look at that intersection as to how do ideas, and in that situation, math ideas, feel hard, and how could they be made more accessible and comfortable by way of technology and technology support. Well, despite having a lot of interest and enthusiasm in that direction, I did find that cognitive science did not go into as much depth or detail about learning as a complex process as I had hoped. And so what that eventually led me to is to pursue doctoral research in the field that I most affiliate with, called learning sciences. And contrary to the naming, learning sciences is not strictly about the processes and mechanisms of learning, but it's also very much about the settings and conditions and technologies, and asks, how do we design different environments and situations and tools and technologies to support learning? Well, following that work, where that period of time I focused heavily on science, cognition and learning, I went on to a faculty position at Utah State University in the United States. And there I began to focus heavily on data, especially data that kids could learn from using wearable technologies. So they would look at activities that they had done and use their knowledge about those activities as resources for helping them to engage with really complex data practices and data interpretation work. About 4 years ago, I made a move to Stanford University here in California, where I have continued on that work, thinking a lot about data, but also very much about computing and computer science. And I've had a lot of opportunities to do interesting work, sort of synthesizing ideas in the field, writing those up, and working with an amazing team of students and colleagues here to try new things out in schools and classrooms and see where we can push the field forward in those respects.
Thanks for sharing your journey with us. It's fascinating, and I always love getting to learn more about how you find yourself in this place that you're in right now. Let's jump into some questions. What data science is a subject that many K-12 leaders, I feel, don't yet have a firm grasp on in their own schools. Can you tell us a little bit about where the science is right now and how it can help to build active participation and critical engagement with students?
That's a fantastic question, and I'd say it's even a very live one for those who are very actively involved in data science and data science education. So if you don't feel confident in knowing what that is completely okay, and I think consistent with where everybody is right now. So first off, just the observation that the world right now is inundated with data. And we are producing huge amounts of it every day, in part because of all of the technologies that we have available and all of the online interactions that we have, but also because with all of the computing that has become more widespread, it's become a lot easier to do a lot of things related to data collection for fields that already would historically do those, such as science. With the combination of so much data and so much computing, it turns out that you can figure out interesting patterns and use particular techniques that combine ideas from math and statistics and computer science to handle these huge amounts of data and be able to find categorizations or patterns or make predictions. So this could, for example, help to better foresee the weather, but it could also help to recommend what would be sort of the best next video that somebody would be most interested in seeing. So there's a whole range of opportunities here, and it's been taken up a lot by industry. It's also been taken up a lot by knowledge building practices such as professional scientists and scholars and researchers, and it's also becoming increasingly important for government at all levels. So with the current state of data science, it has become such an interest area that it started to coalesce, and whole programs and departments and boot camps and other sorts of experiences are forming. And I can say in the United States, there's a groundswell to make sure data science is actively discussed and explored as part of the K-12 experience, in addition to what's happening at the university levels. And some of the things that we're starting to think about is, how can people become more adept at collecting and analyzing and interpreting data to find these sorts of patterns, to also critically judge whether those are real patterns versus sort of spurious ones that are not really particularly meaningful or might be misleading. And for everybody who's been hearing so much about artificial intelligence in the recent months, this current generation of artificial intelligence is so powerful because it is trained through a process known as machine learning. And machine learning basically means there's so much data that we can use to provide as examples to particular algorithms or programs, such that we now have technologies that can behave and solve particular problems that look a lot like the kinds of things that we do as humans with respect to figuring out optimal solutions to problems, or to make recommendations, or to even engage in appropriate sorts of conversations by knowing what are the sort of right words to use in different contexts. So I think with all of that connection and relevance to everyday life and its huge abundance and availability, that makes it a really important thing for students and schools to be talking about. And it has a great deal of consequence and relevance for students today.
Interesting. It really hit me what you said about looking at patterns and combining ideas to handle huge amounts of data to make predictions. Where do you think that the future of data science in particular is going in a way that might be useful for K-12 leaders and learners? Do you think it's mainly in that building active participation and critical engagement, but do you think that there's something technologically or experiential that might be different where the future is leading us?
Yeah, first off, there's a lot of power in being able to make decisions and predictions based on data, and that's not necessarily sort of our ingrained human instinct. We may look for things that confirm our biases, But what we can look to is data as a source of information that can help us to think carefully about what to do next, or how to interpret what all is going on. And I think that can be a very empowering thing for students if they feel like they know how to interpret those, or to hold others to account to say, what is the data that you're basing those ideas on? I think that also, just because with, say, example for youth or for adults, we're using social media, we're using the internet, a lot of what's going on under the hood right now is using data science. And so being able to understand what all is going on in there and why, and that also creates sort of a responsibility for all individuals to think about, am I comfortable with that? When I agree to let my data be shared with, a particular technology or company, are the things that they're going to be doing with that going to be aligned with what I hope for and care about? And can I speak the language to say what it is that I care about and how data could be used differently? So, I think as we look to the future, it becomes part of the everyday conversations and sort of an imperative to participate with and engage with industry, with government, with all of these professional spaces that kids are going to be going into.
Thank you for that. I'm glad that you delved in a bit to data usage and data ethics and how critical that is, especially for young learners as they grow up into adults. Their data is being used. How is it being used in a useful and ethical way? And do they have any agency or choice over that? Let's switch gears a little bit. Often we talk about K-12 for K-12 sake, but really the reason that we're doing that is because we want to drive into success later in life. So how does a good education in your mind help to drive that economic mobility in both work and life?
Well, talking in terms of data and data science, so much of the work that we're doing now, because of the abundance of data and the continual production of it, means that this is a key informational resource for how do we make decisions, whether it's in business, whether it's in civic life. And so being able to tap into that and harness the power of that to make informed predictions, to make sense of the world, is key. And so for education to be an engine for that, it means making sure that we have broad and equal footing so that there is widespread participation and familiarity with the tools and approaches that are being used, so that more people can talk about it, more people can improve it, and more people can use sort of the powerful ideas that come from it. So this has the ability to establish new industries, to get for individuals a leg up to participation in the workforce, and to also just know more what's going on when you interact with technology under the hood, so that way we don't create sort of a myth that there's something else going on, when we can really understand this as how data are being used in very strategic ways.
It's interesting. It makes me think that learning at least a little bit about data science is almost like learning a new language that's going to help you perhaps in higher education and in your business and your civic life, because instead of these things happening to you, you have more understanding about what's happening. Is that correct?
Yeah, I mean, I think this goes back to why literacy comes up so often as kind of a popular term, whether we're talking about literacy around text or computation, but also with respect to data. And to think about literacy means that it's so pervasive and such a part of how we interact and communicate and shape the world, that we've started to think that there are going to be some big competencies that people will need in so many different spaces, and thus it kind of gets on this literacy status. And part of that means being able to interpret it in all the different sorts of situations appropriately, and to also author it. So how can you express and say things with that? So I think that, when you think about this as sort of like almost like a new language that's emerging, data is making its way into all these different sectors, whether it's in our entertainment, whether it's in business, whether it's in the home when you're trying to figure out, your expenses and bills, whether it's in government to sort of figure out policies and resources, whether it's in the creative arts. There's a lot of different ways that this is everywhere now. And so being able to tap that is becoming key as a consumer and a producer.
Interesting. Talk about that concept of literacy and data leads us to this next question of how do you think we can best support youth in making sense of and learning with data, both with and without new technologies, right? Some of us have the capacity to take on a lot of new technologies, but a lot of learners just don't.
That's a great question as well. So one thing to keep in mind is the extent to which data are talked about within schools tends to be very tidy and simplified. You will learn how to work with numbers that kind of, when you run them through processes, they land on an integer value. But real data in so many other contexts aren't that tidy, nor are they small. And part of what's driven the interest in data science is the huge amounts of data that we're working with. So I think one of the most important things that we can do is look beyond these simple and tidy situations and try to have things that feel like they're more messy, and you wrestle with kind of the decision making and uncertainty that's associated with trying to work with actual data. The other part of this is to try to work with some real context. And so whether you have technology or not, there can be ways in which you look at how can we produce data from this experience, whether it's sort of an in-class survey that the students are all contributing to, or observations in the local environment or scenery around you. But being able to produce data and connect with data is very, very valuable and important. And I would encourage schools to try to find things that have relevance and connection to them, and to involve students and teachers through the whole cycle in terms of asking the questions that they have, creating the data and understanding that data are something that we create, and then visualizing the data, interpreting the data, communicating with the data, and wrestling with some of the uncertainty that data inherently have in them, but also trying to figure out how can this still be useful, even though there are some things that will be not known definitively. And that's sort of the trick with data, that to make sure that we can have those conversations and create those, because you always get these small and tidy situations, you don't get a sense for how uncertainty rears its head, and how do we really need to work with data outside of these tidy situations.
It's really interesting because, like you noted, we tend to think about data as being this thing that just sits in a diagram somewhere or sits on a server somewhere. And what I'm hearing from you is, in the real world, it's not like that. It's messy, it's uncertain, and that we should try to find ways for students to interact with that and have the assumption that things are going to be a bit messy and a bit uncertain. Do you feel like doing that is helping to build students' capacity in ways other than just data science? Do you think that there's perhaps some of the kind of 21st century skills that are also being developed in that way?
Indeed. I mean, I think that, we need to do a lot of collaborative and creative work around data to sort of interpret it in ways that are sensible and that make sense to others, to figure out all the different perspectives that need to come in to making sense of data, and what are the consequences of decisions that are associated with data. You would also mention sort of like this notion of tidy data on servers, and even those have a great deal of messiness to them. For any professional data scientist, there's cleaning and pre-processing that are associated. And when it's available, I think it's really important to let students see sort of what are the tools and activities that are involved for real with respect to data. While it may not be the case that the access to all those same technologies is there, I think there are very good approximations and ways that we can sort of point the way in terms of what all would be done there, and to recognize that it's a messy process, but doing the messy work can yield really interesting new perspectives and insights that require our creativity, that require us to communicate with one another and to see how persuaded we are from that, and who all's perspectives are represented and not represented in the data.
Interesting. So I am seeing some skills are coming out around complex problem solving, and perhaps around grit and persistence, when really looking at this and kind of diving into the fact that it is messy, but that there's things that we still need to learn from it, that there's a process of going through that. Thanks for sharing about that. So you recently co-authored a paper on data science education across the disciplines. What do you feel like are some under-examined opportunities for K-12 innovation in data science education?
Well, right now, with a lot of conversations about data, people sort of default to where are the existing school subject areas that we tend to hear that most associated. And among those are math and computer science. And it's definitely true that there is a great deal of math and a great deal of computer science and computational thinking that are involved in doing the work of data science. But there's a concern that we need to be aware of is that many people don't feel like they identify with or comfortable with those particular areas. And also the way in which data have entered all sectors of our lives means that we need all hands on deck, and that the whole range of perspectives in terms of how knowledge is built, not just within math and computer science, are relevant and appropriate. So when we think about what are some of the opportunities, what I would say is think about what are the other subject areas in which data are relevant and are changing the way we do work. Scientists are doing new forms of work now because of the large amounts of data and the means to access those and producing large open data sets that people can use. But also look at the humanities. We can engage with text in whole new ways, and we've started to develop digital humanities and sort of looking at how text can become data when we look at word frequency or usage patterns. And this is sort of the basis of all these really interesting natural language processing, chatbot sorts of technologies that we are now seeing and are getting very heavily buzzed about. But thinking about how the abundance of data, of text as data on the internet is relevant and how it's changing some of our processes there. We think about art and visualization and ways in which that data become expressed and communicative and reflective of points that we want to make. But also you could even look at how is data being used and data science being used to detect fakes versus original works as well. You could look at it for sports and PE. One of the ways in which data science has been really heavily used has been in, trying to put together optimal training programs, optimal team configurations as well. So if you've heard of sabermetrics, and there's so much data that are being collected in there. So the question I ask is, if we think about across the disciplines, are we asking how can a language teacher have productive conversations with their class about data? How can a PE teacher or a coach have that conversation? How can art teacher or music teacher or science teacher have those conversations? We see new ways of looking at social studies and history because we have census data, we have past texts, and there are ways in which we can structure that to start to make patterns stick out and kind of use that sort of lens to think about it. So those are some real areas of innovation, and it doesn't need to be that you have to have done this through your math class, because there are ways in which we try to use the different interpretive lenses and the different disciplinary tools to make the most use of that data and to understand why and when we should consider those data and how much those data actually represent the key things within those disciplines.
Interesting. So it sounds like what you're saying is that there's the opportunity in K to 12 to actually kind of encode data science, not only within multiple subjects, but in between multiple subjects, of having a unit or having a certificate or a small program where students are learning about data science while they're learning about art, while they're in PE, while they're in math. And that sounds pretty fascinating. It sounds like something that they get a chance to learn, but also practice as they're kind of bouncing in between these different subjects.
Absolutely. And for students who feel like those other subjects are their sort of comfort space, it really empowers them to say, a lot about this domain. And when we start to talk about how can we find patterns or make predictions on this, that knowledge of the domain that they have and their familiarity and their expertise becomes a really valuable resource. If they get the message that you have to know this only by way of computer science, or you have to know this only by way of math, then that's going to be discouraging. And in reality, we have to think about how to data intersect with different aspects of the world. And we really need those perspectives in there. So I think it's an empowerment. And it's a way of kind of repositioning why do we engage with data and how does data end up looking different and serving different purposes in different sectors of our lives.
Thank you. Well, I always ask the guests this futuristic question of putting on your big positive hat. Where do you see the future of education going?
Um, right now, I think that we're having a moment to think about artificial intelligence, in part because data have made such very interesting things possible. And so the ability to have tools and conversations about new tools and possibilities, I think, is going to be a very big part of the future of education. I don't think that means that we lose the things that are still intrinsically important, such as the relationships that we form, that the guidance that, excellent teachers and excellent curricula and programs will support, but we have additional things at our disposal, and we have an imperative to understand how those things work and why those things work the way they do in order to select the best ones, and also to know when and when not to rely on those. So I think that means understanding how what we're talking about as artificial intelligence is sort of a product of this thing we call machine learning, which is based upon this abundance of data that we're gathering. I think also that, as the ability to do so much with data and to communicate so freely in so many different spaces, we're going to be having this interesting tension where we're going to be looking at how can we maintain sort of uniformity of opportunity and experience, but also be very deeply responsive to and understanding local context and also preserving local context. There's so much rich knowledge that different spaces, countries, communities have. And there's ways in which, if we do too much of a uniformity on that, we don't give a chance for those things to surface and to offer their richness to the larger discussion. So I think what we're going to be seeing in the future is continuous discussion about how these things intersect. And where I see things going is that optimistically, we will give tools for more voice for all of the different communities, so that way we can engage in productive dialogue and develop new knowledge from perspectives that we may not have as prominently, and that giving access to some of the tools and language that we use, some of which is related to data specifically, is one of the means to do that.
Interesting. Thanks for sharing about that. I'm also excited about where machine learning is driving AI right now. We have some great questions from the audience. Can we take a couple minutes to answer a few?
Absolutely.
Thank you. We have one here from Sandra who asks, how could low budget schools that really don't have technological tools or even electronic devices, is there anything they can do to help develop data science skills?
Yes. So let me play this out in a couple of situations. Let's say one where in a situation where the school may be limited on resources, but students may still have mobile devices, that becomes an asset and a resource. If you're in a situation where that is not something that is possible, then what we're going to want to focus on is how can we produce data and think about the issues where we need to create information that is structured similarly and pooled together, that can involve how would we draw out the visualization for this with these data points, and when and how, when the opportunity in the future may present itself, technology could help us do this, which takes a bit of work now, faster. But even with the amounts that we can get, say if you have a class of 20 students and every student collects 5 data points, you have 100 data points there, and you have a lot of opportunities to work with that. So I'd say looking at what are the resources in there, and in ways that data visualization does not have to be rendered by a computer. There's a lot of different ways that you can use objects around you to represent things, that you can use drawings to do that, and to talk about what are some of the features that you care about or see in the data, and learn about those, because at all levels of data science and with all different sorts of tools, those are sort of the persistent topics and questions. So I think that there are ways to engage with that. And it does not necessarily require the technology to collect the data. What we'd want to do is that if there's a future desire to participate in how data science is being used in these heavily technological spaces, so for people to understand why is that technology useful in that time, and how that can do some of the work, so that way we can focus on these other portions and make sure those other portions, which would involve interpretation and communication around it, really well, in the absence of technology.
Interesting. I'd like to ask a little bit of a follow-up on that for, again, these schools that are low tech or maybe even no tech. Are there opportunities for them to learn data science expanding not just within the classroom, but other parts of the school and even outside, perhaps to other local schools, to get more of a connection with the community? Any thoughts there?
Yeah, I mean, so with further connections to community, I'd say there's chances to look at many different facets of daily life, whether it's at the home or outside of the schoolhouse, and to look at ways in which we can make comparisons and look for similarities across these different contexts and see where can we make pooling of information or communicating across these spaces another asset as well. So I think that finding ways and sort of helping students and teachers become attuned to how can we look at regularities and differences and reconcile those in ways that can communicate across these spaces is a really great way to get those conversations started with data, and to also help students and schools to see all the different opportunities, and it's not just bound to the walls of this particular classroom. That, you could look at how much time does it take to walk back and forth to school each day, and that becomes a source of data. Just make sure that you record it and that you think about what are the issues that are involved in recording that. If you want to look at different sorts of things that happen in everyday life, which sort of aligns with this perspective that I work a lot with called the quantified self, and just trying to see where are sort of these things that kind of recur a lot. If you want to use other schools or other sites as resources, as audiences, or more sources for data to work together and to pool things, and to also discuss why is it important to create standardized data sources so that way all of these things can work together, that can create a really authentic context for doing data work as it really appears. It's just in outside of those contexts, there's going to be these conversations by way of technology, but it's the same issues that come up.
Thank you for that. We have another question from Satish who's asking, can you speak about a few use cases on how K-12 institutes might be able to use data science to get better ROI? And that's presumably on the schooling process?
Yeah, so on the schooling process, I'll say in terms of what kinds of experiences for students is, I would say to do full cycles of inquiry with students, so that way they can see how the decisions made early on have consequences for portions later. Currently, it's done piecemeal, where it's like, let's take this idea, which is let's look at the measure of center. Let's look at the mean or the median. And so let's hope that you know how to use that and think about that in relation to a bunch of different things, which is not as meaningful as following things through, which is, what is the question am I trying to ask? What data would we collect from that? What do those data capture well? Knowing at that time that we made those decisions, what things are those data not capturing well? And then as this process continues, when you finally have some conclusions, reflecting back on what did this ultimately tell us and what did this not tell us, and why and when did those things become useful, such as the measure of center or some of these other things that we tried to teach outside of context. So I would say giving as many opportunities to go through all portions of that and not treating them as piecemeal is a very important way to get a better return on investment, because you're thinking about the whole cycle in which data are used and the consequences that are associated with these important but seemingly small decisions that come along the way. The other thing I would say is for return on investment is to find things that students are knowledgeable about to examine by way of data, so that way they can see how the connections and gaps reside in that move towards data, and that they're empowered to see that. Otherwise, we get this sense that data are sort of absolutely right in all ways without knowing that there is more nuance and complexity in the world. And we're always going to be needing to have that dialogue. So if we always have students work with data that don't really have anything to do with them, they're not positioned to know that those data have certain limits to them. But if it's something that they know a lot about, they can say that is one way to capture that, and that is one potential pattern that comes out of that. I can think of others, and then to ask the question, how would data be generated to ask some of those others? And I think that that's another important way to, get as much return on investment as possible.
Thank you. So what I'm hearing is both make sure that the decisions you're making around data science are not just kind of disparate decisions, but you're creating an ecosystem to really get more ROI, and also making sure that what you're doing is relevant to your learners, to your students. So they're more bought into the process, and you're going to get higher ROI out of that. So we have another good question from Gloria. Are there any K-12 sites that you've seen that are really leading the effort on showing students how to make sense of data?
In the United States, there's a number of schools that are doing work with data, and I'd say a number of fields and disciplines. So it'd be hard to say this particular school alone, because I think there's such a multitude of these. And there are increasingly more and more resources that are being produced for data science education within K-12. So one resource I would say is to look at, there's an organization that has emerged to help synthesize and bring these together called Data Science for Everyone, but it's the number 4, so Data Science number 4 Everyone. And that's a community that is helping to share out all of these different resources and activities that are happening around the country, and to sort of offer, lessons and ideas for that. I would say also that the examples of schools and projects that I've seen, oftentimes they're anonymized because of the research process, but when they're thinking about data in broad terms outside of just math or just computing, are very exciting. When they're doing something really rich with data in the science classroom and actually trying to figure out all the messy complexity or use some of these resources that are available online. When they're doing data in art class and they're actually making data visualizations and trying to explore what's hard to express and what is important to express and what do people see and think about it. And I'm also doing some work right now on English language arts with some partner schools and data in that context. So, just to give some examples, but I think that this is an opportunity to be inventive because it's still a fairly blank slate. We know it's important. We're starting to get glimmers of examples, but there's so much that we can do here in so many different ways in K-12.
Thanks, and thank you for surfacing the data science for everyone as just a good place for folks to start digging into this subject. We have another question from Parav, who asks, do you believe that using at least basic programming to perform data manipulation is something that should be taught outside of a computer science classroom in K-12 schools?
Yeah, so for my perspective is that, as somebody who follows sort of constructivist epistemology, all knowledge is built on some other knowledge that we've got. And so the things that we know how to do in programming is based on things that we know about how to structure information and sequence things and problem solve. And that sort of goes to this idea that we call computational thinking. And so I think the question here is, what does it mean for basic programming? And where does computational thinking reside in that? And there are amounts and levels of complexity that we can consider, and what's the appropriate sort of dosage of that. But I think it would be very reasonable because this is part of the toolkit. If we just sequester things, it kind of gives the message that only resides when you do things in this way. And in truth, just like the way we use language and text and the way we use computers now, it does not reside strictly in that. And these are opportunities to see how and where they are useful. And I think that there are ways to access that because there is relevant prior knowledge to understanding it. But we may want to think about, well, would a block-based programming experience support this? Would things that are sort of pre-made and there's only a small portion that we need to really understand and not have to think about these other parts as much in order to see how does this work? And so I think it's a question about sort of dosages and what level of complexity, but I do think that those are all pertinent to the things that we think about in programming and in computational thinking and in computer science. It's just that those spaces, computer science and programming, go really deep into those. But I think we can have meaningful and worthwhile engagements with it, whether you're just doing it by way of Excel and a little bit of scripting or a spreadsheet in there, or if you're even trying to sort of articulate what are the rules to build a way of visualizing the data if by hand. And so there are ways in which we can sort of make contact with the ideas that programming and computer science tries to do.
Thank you. We have time to slip in one more quick question and answer because Isaac's asking a significant issue could well be teacher literacy and competence when it comes to data science. How might schools work to address that particular issue?
Yeah, so, I think one important thing is to get the message across that when we start to think from a data paradigm, is that data have uncertainty associated with them, and that part of the game is to be uncertain and know when to be uncertain. And so in that respect, I would say if you feel uncertain, that's sort of the right orientation for teachers to have in the first place. Then the next thing is to give them experiences themselves to work with actual data and to sort of encounter what some of those complexities are and to have conversations with other teachers as they try things out and share that knowledge with their students. But oftentimes we're trying to give things a little bit too prepackaged, and it doesn't give a chance for the teachers themselves to know and anticipate some of those complexities. This could happen in the context of schools that review internal data, but to have those conversations around internal data, such as what is sort of your measures of performance or attendance, but to talk about them in the ways that allow for that messiness and allow for that uncertainty to be in the room. But then even understanding that with that uncertainty, how does one sort of make some sort of inference or claim that seems justified? So, the short answer is give teachers a chance to work with data and to represent it appropriately, which is that, there are no perfect right answers. There are careful ways of thinking about it and ways of feeling comfortable with knowing that this is sort of a probabilistic thing that still has the power to get us somewhere.
Thank you. Well, Victor, we've come to the end of our available time today. I want to thank you so much again for sharing your own expertise with us. I also want to again thank Digital Media Academy for sponsoring this series. You can find out more about the leading STEAM schools in the world membership program on the website at digitalmediaacademy.org/schools, or contact us anytime at info@digitalmediaacademy.org. We'll be taking a short summer break since many of our viewers will be taking well-deserved holidays, but we really look forward to seeing you all again this fall with a new set of featured speakers. On behalf of Digital Media Academy, I'm Chris Bennett, and I wanted to thank everyone who's able to join us for this session, and we wish you a fantastic rest of the day. Take care.